Okay, so in this video, I'm going to talk a little bit about common denominators. And in particular, we're going to start by looking at the common denominator between sevenths and fifths. Now, your book gives you a nice way of doing this. It's a very numerical technique that would say something like, okay, if I want a common denominator between sevenths and fifths, I'm going to list multiples or a counting pattern of sevenths. So 7, 14, 21, 28, 35, and I would keep going, 42, 49, etc. Okay. I'm also going to list the counting pattern for 5. 5, 10, 15, 20, 25, 30, 35, 40, etc. And what I'm looking for is I'm looking for a match. So I'm looking for a number that appears on both lists. If I want the least common denominator, I want the smallest number. So looking at these lists, you notice that 35 appears on both of them, which tells me that my common denominator should be 35ths. Okay? It's a really nice method. However, I want to show another method that involves our area model and then a number line model that can also get us to that common denominator, in this case of 35. So we don't have to have prior knowledge. We don't have to know that our common denominator is going to be 35. It's just going to pop out for us. Okay. So this might look a little bit weird. I have my numerators are smiley faces. My numerators are smiley faces in this case because I don't care about them right now. I'm focusing on the common denominator. So I'm looking for what's common between sevenths and fifths. My numerator is irrelevant when I'm doing common denominators. Okay. All right. So I'm going to start. And I'm going to start and say, okay, can I show sevenths on this area model? Well, sure. Sevenths just mean that my whole is divided into 7 equal pieces. Remember that our denominator tells us the number of equal pieces that our whole is split into. So I'm going to take my area model, my rectangle here, and I'm going to divide it into sevenths. 1, 2, 3, 4, 5, 6, 7. So I'm going to show 7 pieces. Now I'm sketching this on the board, and I would expect the same of you. I'm going to do my best to make those pieces as equal as possible. And there's 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, 7. So notice that now I've shown sevenths. So my little rectangle is split into sevenths. Okay. Now I'm also going to try and show fifths. Now I know what fifths mean. Fifths mean that my whole is split into 5 equal pieces. Okay. Now I'm going to be clever here, and I'm going to show my fifths going this way. So for a minute, pretend that those blue lines don't exist. And I'm going to now split this into fifths by drawing fifths this way. So 1, 2, 3, 4, and 5. So if I just look at the purple strips, I've got 1, 2, 3, 4, 5. So those purple strips are showing my fifths. Now, here's what's cool about this area model. I showed sevenths this way. I showed fifths this way. And now look, my grid, my area model, has been split into how many equal pieces? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So I've now shown 35 equal pieces is going to be my common denominator. So my area model has shown that common denominator of 35. Okay. Now, one question to ask ourselves is this the least common denominator? In other words, is that the smallest number? And in this case, it is going to be our least common denominator. The reason I know that mathematically speaking is 7 and 5 are what's known as relatively prime, which is a fancy way of saying 7 and 5 don't share any common factors. If I look at my list here, my multiple list, 35 is the first number that is shared on both. Okay. All right, so let's work a little bit more with this area model and then do the number line model. So let's think for a minute. Can I use this? Now this is going ahead. We haven't gotten to addition of fractions yet, but let's just peek ahead. Can I use this to show 1/7 plus 1/5? Well, now notice that I put in numerators, but numerators just tell me how many of this size piece that I have. So 1/7 is saying you have one piece and its size is a 7th. But I know where sevenths are living in this model here. If I shade in one of those blue bars, that's 1/7. So I've shown 1/7. Okay. Now, I have to be a little bit careful here, and we're going to talk more about this when we get to our addition of fractions section. But to show 1/5, right, I need to color in one little bar here, one little row here. That's 1/5. But technically I've done something a little not okay here, and then I've double counted this square here. Notice that this square is colored in blue, so it's counting for my 7th, and this square is colored in purple, it's counting for my 5th. I don't want that. So I'm not going to count it for my 5th, and so I'm going to say, oh, I'm just going to move that extra little 5th piece down there. Okay. So now I've shown a 7th, and I've shown a 5th, and we can just count to get our answer. All together, what do I have shaded? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So altogether, I have 12 pieces shaded. Each one of those pieces is a 35th of my whole. So 1/7 plus 1/5 is 12 35ths. Okay. I'll leave it up to you to try and show subtraction if you want. It is a bonus, you don't have to. All right, so now what I want to do is for the same little guy, erase this guy, I want to see if I can show this using a number line. Well, this is going to get a little bit messy, but messy is okay. All right, here is my number line. Okay, and I'm actually going to do this on 2 separate number lines to show 2 separate ways for doing this. Okay, all right, so here's one way to think about this. I can start by showing 7ths. Again, I know that 7ths mean I'm taking this interval from 0 to 1 and splitting it into 7 equal pieces. So again, I'm going to try and do that freehand here. And there's a 7th, 2 7ths, 3 7ths, 4 7ths, 5 7ths, 6 7ths, 7 7ths. So notice I have 1, 2, 3, 4, 5, 6, 7. So these little blue markers show my 7ths. Okay, here's where it gets a little bit fun. Now we want to try and show 5ths. Now one thing that I could try and do is just freehand my 5ths in there. Oh, but that's going to get a little bit confusing. Instead, I'm going to take each 7th and split it into 5 equal pieces. 1, 2, 3. Ooh, that's terrible. Luckily I'm doing this on the board, so I can try again. So I'm trying again to split the 7th into 5 equal pieces. 1, 2, 3, 4. So 1, 2, 3, 4, 5. I'm going to do that with every 7th here. 1, 2, 3. Okay, so just a quick check. Notice that this last 7th I split into 1, 2, 3, 4, 5 equal pieces. So I've taken each 7th and split them into 5 equal pieces. Now, if I were to count each little tick mark, how many tick marks would I have? I think I'd have 35. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So each one of these little tick marks is now representing a 35th. So notice that again, out popped that common denominator that we saw before. Now I can do this in the reverse order if I so choose. So again, I'm going to break up my number line from 0 to 1. This time I'm going to start by showing 5ths. So 0 to 1, I'm going to split this into 5 equal pieces. Again, I'm freehanding, that's okay. 1, 2, 3, 4. Notice that I used 4 tick marks, and that gives me 1, 2, 3, 4, 5 equal pieces. So each one of these is a 5th. Okay. And then just like we did before, I'm going to take each of these 5ths and divide it into 7ths. Here I took my 7ths, divided them into 5ths. Here if I do this, let's see if I can freehand this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And again, all together, I now have 35 little equal, in theory, equally spaced tick marks. So each one of these little tick marks shows a 35th. Okay. So 2 ways, area model, number line model. Most people find the area model a little simpler. The number line model is a little bit more abstract, a little bit more complicated, but we can use both of these models that we've been using to show common denominators.